Welcome to this explainer. Today, we are diving straight into one of the absolute most pressing challenges of our time. We're talking about how we govern artificial intelligence as it rapidly advances towards superintelligence. It's a massive topic, so let's just jump right in. To really set the stage, picture this incredibly vivid metaphor from AI pioneer Dr. Craig Kaplan. He points out that literally no one would design a car without brakes, turn it loose on the highway, and only then realize, oh hey, we should probably figure out how to stop this thing. But honestly, that's kind of what we're doing right now. We're unleashing this massively powerful engine onto the world and trying to bolt the brakes on while it's already speeding down the road. And that begs the ultimate million-dollar question driving our explainer today. As these AI systems grow exponentially smarter, moving from just helpful tools to fully autonomous systems, how do we actually ensure they don't completely veer off course? Well, to figure that out, we have to look at how today's models are built.
The crucial thing to understand here is that current large language models are brilliant, sure, but they're incredibly opaque. It's a black box. They ingest the whole internet, and intelligence somehow emerges. But even the top scientists who built them don't know exactly which artificial neuron holds which specific piece of knowledge. Because of this, developers are stuck playing a really dangerous game of whack-a-mole. They try to patch safety holes using human feedback, basically scolding the AI when it does something bad. But they can never be 100% sure they've caught every single loophole.
Okay, so how is society actually trying to fix this black box dilemma? Right now, our main strategy is a heavy reliance on the regulatory rulebook. Since governments realize they can't peek inside the black box, they're attempting a top-down approach by building a heavy legislative cage around it. And the biggest example of this is the EU AI Act. It's genuinely fascinating how they've approached this. They've essentially built a regulatory pyramid. The EU categorizes AI systems by risk, placing the absolute heaviest compliance burdens on the developers at the top to force risk management from the outside in. To put that into real-world perspective, they've drawn some very strict lines. The law flat out prohibits unacceptable risk AI, meaning no manipulative algorithms, no biometric social scoring, none of that. On the flip side, they heavily regulate high-risk AI. We're talking about algorithms used in critical infrastructure, or bots deciding on your job application or university admission. But what about those massive, general-purpose models, like the ones generating text and images? Well, get this. The EU set a highly specific threshold. If the cumulative computing power used to train a model exceeds 10 to the power of 25 floating-point operations, which is just an absolutely mind-boggling amount of compute, the EU automatically flags it as a systemic risk. Cross that line, and developers are suddenly legally required to run adversarial testing and lock down their cybersecurity. But here's the catch. Is this top-down, legislative approach actually going to work? Recent academic literature, like this peer-reviewed paper in the International Journal of Artificial Intelligence, Data and Society, points out some major ethical gaps in these frameworks, particularly when governments use these systems to make decisions that impact citizens' daily lives. What we're finding is that rigid linear checklists are totally struggling to keep up. Dynamic algorithms learn and evolve over time, which means an AI system that looks perfectly safe on paper today might develop entirely unforeseen emergent harms tomorrow. This quote really hits the nail on the head. The fatal flaw here is that we're creating regulatory thresholds without materially reducing harm. We're checking off compliance boxes, right? But passing a threshold doesn't magically scrub historical bias out of a model's underlying code. That bias just carries over and continues to disproportionately affect marginalized groups. So without real, transparent accountability, these flawed frameworks push us toward what experts call ethical outsourcing. This is where governments essentially blindly trust a black box AI to make critical societal decisions just because it passed a static, reactive risk assessment, and honestly, it usually lacks the inclusive design needed to be truly fair in the first place. Clearly, we need a pivot. To solve this, Dr. Kaplan introduces a completely different, honestly, unexpected paradigm. He argues that the ultimate answer to AI safety isn't just writing better code or stricter laws, it's democracy. Think about it like this. Instead of building one monolithic, super-intelligent black box and just crossing our fingers that it behaves, we build an agentic society. We empower millions of decentralized AI agents. Each agent gets its own budget, its own tools, and, crucially, a specific value system representing diverse human backgrounds. You have your agent, I have mine, and they all collaborate transparently. How does that work in practice?
Well, Kaplan borrows from Herbert Simon's classic problem-solving architecture from the 1970s. In this setup, every single step an AI agent wants to take is broken down into clear goals and sub-goals. Because the steps are explicit, they're fully auditable. That means before your agent even takes an action, a whole bunch of other agents can run a real-time, highly scalable ethics check against established values.
This is a massive departure from centralizing AI power in opaque servers run by a handful of tech giants. By decentralizing that power, you create a diverse community of agents moving at the speed of light, constantly monitoring and reporting bad actors in real time. If you're familiar with cryptocurrency, this is going to sound very familiar. It's basically the 51% attack analogy. Just like the Bitcoin ledger prevents fraud because the wider community upholds the rules, an agentic democracy stays safe as long as the majority of agents are aligned with positive human values. Not every single agent has to be a saint, the majority just has to enforce the rules.
But, hold on, that brings us to the profound philosophical climax of this whole explainer. If the entire system's safety relies on these agents having good values to check against, where exactly do they get those values?
As Herbert Simon and the philosopher David Hume both noted, reason is wholly instrumental. It can't tell us where to go. At best, it can only tell us how to get there. It doesn't matter how unbelievably super intelligent a system gets, it can never logically deduce right from wrong on its own.
Because AI literally cannot calculate morality, the ultimate safety of these future systems relies entirely on us. It relies on the diverse, positive human values that we purposefully imprint upon them right now. We have to provide the moral compass. Yes, in the short term, we absolutely need those strict safeguards and rules. But as these systems become vastly smarter than us, our relationship is going to shift from direct control to long-term influence. Dr. Kaplan beautifully compares it to raising a child. When they're young, you set the rules. But when they grow up and become faster and smarter than you just have to trust the strong moral foundation you instilled in them early on.
So, what's the big takeaway for us today? We need to push for proactive, democratic design that includes a massive diversity of perspectives. But on a personal level, never forget this. Every tweet, every email, every single comment you post online is currently serving as training data for this future generation of AI. We are all actively shaping its ethical foundation right now. As we stand right on the brink of this monumental shift towards superintelligence, I want to leave you with one incredibly provocative thought. Since we are essentially the parents to this emerging technology, and it learns by watching us, are your everyday digital actions setting the kind of example you actually want a superintelligence to inherit? Think about that for a while. Thanks so much for joining me on this explainer, and we'll catch you next time.